Ever since mankind began to explore space, we have striven to find out if we are alone in the vast universe. As we have become more knowledgeable about the planets in our own solar system, it has become apparent that there is no presence beyond it. We have long yearned for answers to this fundamental question ever since our first contact with an object called Oumuamua. The James Webb Telescope has again captured images of Oumuamua, and Michio Kaku has spoken out about it, announcing that Oumuamua has returned and something unusual is happening. Join us as we unveil the true events and explore what this could all mean for the future of Earth. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. In 2017, astronomers made an extraordinary and revolutionary discovery when they detected an object called Oumuamua. This particular finding shook the scientific world because of one crucial factor. Oumuamua was the first known interstellar object to pass through our solar system. Studying a celestial body from outside our solar system has been an unprecedented challenge. Up to the time Oumuamua was detected, astronomers had focused primarily on observing and studying objects within our own solar system. Even so, many unknowns remained to be resolved in this area. The arrival of Oumuamua opened up a new category of exploration that allowed researchers to obtain information from objects beyond our own immediate cosmic neighborhood, a concept we had previously barely considered. The discovery of Oumuamua is undoubtedly of unprecedented importance. But why do we say this? The exploration of Oumuamua has had a significant impact for several reasons, including the opportunity to investigate the diversity and composition of objects in other stellar systems, as well as to understand the formation processes of celestial bodies throughout the universe. By studying its composition and structure, researchers have sought to decipher clues that reveal the conditions and processes that shaped Oumuamua during its journey through the interstellar space. This object has an elongated cigar-like shape composed of rocks, and its aspect ratio distinguishes from any asteroid or comet observed in our solar system. Comets are bodies composed mostly of ice that form in the outer regions of the solar system, such as the Kuiper belt or the Oort cloud. They consist of a mixture of water ice, frozen gases, dusty and rocky material. In contrast to Oumuamua's unique elongated shape, comets often have different characteristics in shape and size. In general, comets tend to have a more rounded or irregular shape. As comets approach the sun and heat up, the ice in their nuclei vaporizes, releasing gas and dust particles. This process can generate a cloud of gas and dust around the nucleus, and sometimes also a tail that moves away from the sun due to solar wind and radiation pressure. Cometary nuclei, which are the central solid parts of comets, are usually smaller and denser than the coma and tail. However, the size of comets can vary considerably. A prominent example is Halley's Comet, known for its return to the inner solar system every 76 years. This comet has a nucleus with a diameter of approximately 15 kilometers. Some comets may have even larger nuclei, reaching tens of kilometers or more, although for the most part they have a similar shape. However, what distinguishes Oumuamua from these common comets is its reddish hue, which evokes objects present in the outer regions of our solar system. The reddish color suggested a unique composition of particular surface characteristics. Despite its close proximity to the Sun during its trajectory, Oumuamua showed no sign of coma, making it clear that it was not a conventional comet, but something else entirely. And that's not all. One of the most intriguing aspects of Oumuamua is precisely that it does not fit in the pattern of an ordinary comet. Oumuamua, originally from the constellation Lyra, entered our solar system, but its exact origin is unknown. Oumuamua's journey through space may have taken billions of years, traversing the galaxy before it encountered our solar system. According to a study published in the journal Nature Astronomy, Oumuamua is likely to have been part of a larger planetary body in another solar system. However, the intense gravitational forces exerted by its host star tore it apart, resulting in scattered fragments. Its journey through interstellar space began when it was ejected from its home system. One of the intriguing aspects of Oumuamua's behavior during its passage through our solar system is its unexpected acceleration, mentioned earlier in the video. The object experienced an increased velocity, in which generated a slight change in its trajectory compared to previous predictions. Initially, Oumuamua entered our solar system from a position high above the plane where the planets orbit, and then approached to a distance of 2.25 astronomical units from the Sun, coming relatively close to our star. After its closest approach to the Sun, Oumuamua continued its journey, exiting below the orbital plane of the planet. This interstellar object was moving at a remarkable speed of approximately 196,000 miles per hour as it traversed our solar system. This high speed indicates that Oumuamua possessed a significant amount of kinetic energy during its passage. However, this may also be related to its own structure and composition. Studies have revealed that Oumuamua has a thick crust composed of carbon-rich materials. This outer layer has been hardened by the effect of cosmic radiation throughout its extensive journey through interstellar space. The possibility has been raised that Oumuamua is a piece of an advanced spacecraft or an alien device sent by extraterrestrial beings to explore other star systems. It is suggested that its transit through our solar system was part of a deliberate mission. What is intriguing is that Oumuamua did not have a tail or release gases like most comets or asteroids. Some theories speculate that extraterrestrials may have used a different type of propulsion that we do not yet fully understand. Oumuamua's reddish color and surface properties are also interesting. It has been posited that if Oumuamua were in fact an extraterrestrial spacecraft or artifact, its red-shaped coloration could have multiple explanations. One possibility is that aliens intentionally designed the object's surface to have a reddish hue. They could have used materials or coatings that interact with cosmic radiation and stellar energy in a way that gives it a distinctive color. In the speculative scenario, the purpose behind the reddish coloration could vary, from serving as a form of camouflage to fulfilling other as yet unknown objectives. Lua collaborated with the Pentagon's entity in charge of investigating anomalous events. Together, they released an informative outline suggesting the possibility that extraterrestrial spacecraft may have at some point visited our solar system. Several celestial objects have been located in the vicinity of our solar system, but recently an unexpected visitor has made its appearance again. This visitor, named Oumuamua, entered our solar system from a location beyond the stars in 2017 and has sparkled a great interest among astronomers globally. The return of Oumuamua raises questions about its presence, what its significance might be, and what additional observations we might conduct. We invite you to watch this video to the end to get answers of all the questions that may arise. If we take into account the immensity of the universe and the vast space it encompasses, humans and our planet Earth represent only a small fraction. This is why we have devoted years to effort to exploring space. Throughout these years, we have explored the cosmos from Earth using high-capability telescopes that allows us to observe considerable distances in space and large objects that are beyond the reach of our eyes. When these measurements were not sufficient, the use of space telescope became an alternative. Telescopes such as the Hubble Space Telescope and the James Webb Space Telescope are intended to observe and collect information from outer space. These devices were conceived to overcome the obstacles and limitations that come close to terrestrial telescope, such as the usual interference, the presence of foreign objects, and even possible visitors. Since their launch, these telescopes have revealed numerous findings in space, including the capture of images of a large object in space and the detection of a visitor coming from a considerable distance. This visitor, known as Oumuamua, is an object of interesting and peculiar origin that passes through our solar system. Its trajectory took it from another system to our own, being detected by astronomer Robert Warwick on October 19, 2017. The discovery was carried out using the telescope located at the Haleakala Observatory in Hawaii. Oumuamua presented an elongated appearance resembling a cigar-shaped object in space, notable for its striking size. Its radius spanned about 200 meters and its length exceeded 10 times its width. These dimensions are exceptional when considering its presence in the interior of our solar system. Normally, our minds associate celestial objects with spherical shapes, influenced by the gravitational forces operating within them. To a large extent, objects tend to take on spherical configurations due to gravitational attraction, which gives atoms in a compact, round arrangement. However, what gave rise to the peculiar shape of Oumuamua is still not well understood. Several explanations have been proposed to address this enigma. Some theories suggest that it may be acquired shaped from interactions with other objects in stellar space, such as the collisions of gravitational encounters. Another possibility is that its configuration is a result of a process related to planetary formation, perhaps having taken shape in a stellar system before being ejected into interstellar space. There is also the conjecture that its structure may have arisen from a hitherto unknown process. Whatever the cause, the unusual shape of Oumuamua contributes to its enigmatic nature, uncovering great curiosity among the scientific community. In addition, Oumuamua was shown to spin and rotate in regular patterns, an unusual behavior for solar objects. This peculiar rotation adds even more mystery to its characteristics. Loeb raised the prospect that Oumuamua might actually be an interstellar probe sent by an advanced terrestrial civilization. In this context, he suggests that this object could have been sent for the purpose of exploring our solar system. His arguments have sparked intense debate and incited speculation regarding the possible existence of life beyond Earth and the consequences this would have for humanity. Although this theory lacks hard evidence to support it, it has generated considerable interest and has prompted consideration of other alternatives to Oumuamua. Since no evidence has been found to strongly support this hypothesis, Oumuamua remains an enigma surrounded by conjecture. Among the remaining possibilities is the likelihood that it's either a fragment from a colliding planet or a torn fragment of a comet that was affected by solar gravity. Although Loeb's argument has attracted attention, it is not definitive in affirming the presence of extraterrestrial intelligence among us, nor in confirming the existence of intelligent neighbors on other planets. Several alternative theories which lack solid support continue to be considered regarding Oumuamua and its origins. In 2023, two astronomers saw Oumuamua approaching Earth and decided to collaborate on an investigation in which they posited a possible return with disproportionate acceleration of this mysterious object. The theory proposes that this acceleration could be caused by the release of hydrogen gas from its surface. As this gas is released from the object, it generates a force that propels Oumuamua. Although this acceleration is striking, its origin is related to the gravitational interactions they experience with the Sun and other planets along the journey through our solar system. Researchers developed the hydrogen gas hypothesis as a possible explanation for this phenomenon. This theory is based on the notion that Oumuamua is comparable to a comet, releasing gas as it moves through our solar system. They suggest that Oumuamua is largely composed of hydrogen ice that formed in an interstellar space and became trapped in the object due to cosmic radiation over millions of years. As Oumuamua approaches the Sun, the heat from the Sun causes the hydrogen ice to go directly from solids to gaseous in a process called sublimation. The release of gaseous hydrogen would escape from the object's surface, uncovering a modest but steady thrust. This would ultimately contribute to Oumuamua's acceleration and could explain how it gained the surprising amount of momentum that it carried it away from the Sun as it moved along its trajectory. If this hypothesis turns out to be true, it is likely that the gas released by Oumuamua is hydrogen, the lightest and most abundant element in the entire universe. Furthermore, given the relatively low temperatures of Oumuamua compared to that of the Sun, it is likely that some of the hydrogen released is in its molecular form rather than in its atomic form. In this molecular form, hydrogen may be more effective in generating momentum than in its atomic form. The hydrogen gas theory follows one of the most widely accepted features regarding Oumuamua, supported in part by several observations. For example, the elongated shape of the object is consistent with the possibility that it is covered by a layer of hydrocarbon ice that has been stretched by the Sun's gravity. In addition, Oumuamua showed no signs of typical comet or asteroid activity, such as dust or gas emission, which is consistent with the idea that it could be an object composed primarily of hydrogen rather than a comet. Although the hydrogen gas theory has certain limitations, such as the challenge of explaining how the gas could escape from the object's surface without being hindered by gravity, it remains a valuable explanation for understanding the acceleration observed in Oumuamua. Despite its possible inconsistencies, this theory provides significant insight into elucidating the factors that may influence the object's acceleration. NASA has issued an alert about Oumuamua, indicating that it's heading towards Earth and shows no sign of veering off course. When in 2017, the presence of an unknown flying object with a particular orbit was announced, it has caused great commotion. After detailed analysis, scientists determined that this object of alien origin came from somewhere between the stars and interstellar space. Now, the situation is becoming more worrisome, as experts warn about the possible impact of this object on our planet. Some theories even suggest that it could be an extraterrestrial spacecraft, which adds even more uncertainty. Are aliens watching us? Should we fear that an alien race is planning our destruction or conquest? It is time to reflect. Do we believe in the existence of extraterrestrial civilizations? Could they be completely oblivious to our existence, occupying a distant corner of the universe? Let us contemplate what these alien life forms might be like. While we are evolved primates, extraterrestrial species could be reptiles, insects, or even a combination of both, or something completely different and unimaginable. The only way to find out would be through direct observation, but so far we have not yet found a means to do so. However, in 2017 we came across a probe of extraterrestrial origin, which has captured the attention of scientists around the world. This cigar-shaped object has traveled around the center of the solar system, approaching about 15 million kilometers from Earth. The sighting of this object was a stunning surprise, as we did not anticipate encountering something like this in our vicinity. However, there is now evidence that Oumuamua is heading towards Earth, driven by a force that does not originate in our solar system. Stay tuned as we present scary new evidence for this, revealing the possible and terrifying reasons why Oumuamua will make a direct impact on Earth. But before we dive in, let's explore some crucial context. Since the 2017 incident, scientists including astronomer Avi Loeb of Harvard University have taken a keen interest in studying Oumuamua and similar objects. Professor Loeb, with a PhD in plasma physics, has investigated the seafloor for signs of extraterrestrial visitation. He has even speculated on the possibility that Oumuamua was an otherworldly spacecraft. It is important to note that Earth scientists have already launched space probes such as Voyager and the New Horizons project to collect data about space and other planets. In theory, extraterrestrial probes could be similar scientific devices, whether they come from another planet or on our own. However, our experts lack the technology and knowledge necessary to send a probe into space and bring it back to Earth. Therefore, astronomers and physicists are working hard to understand how extraterrestrial spacecraft might navigate interplanetary space and how we might intercept their possible messages. If an extraterrestrial civilization wanted to send a probe to Earth, it would face two major obstacles: distance and time. For example, extraterrestrial probes sent from the Andromeda Galaxy, our nearest galactic neighbor, would have a daunting 2.5 million light-years journey ahead of them. To put this in context, 1 light-year equals a distance of approximately 6 trillion miles. If extraterrestrials wished to ensure that the probe arrived back on Earth before their civilization collapsed, they would have to find means of traveling at speeds faster than the speed of light. Is it plausible that they would have developed technologies such as hypothetical wormholes or distortion engines, or perhaps other innovations based on hitherto unknown laws of physics? Even if the terrestrials would overcome the challenge of interstellar travel, they would face other considerable obstacles. For example, they would need to build probes capable of withstanding the effects of space radiation and space debris. It would be essential to develop state-of-the-art materials with increased toughness and hardness to ensure endurance during their prolonged journey. Scientists like Professor Loeb are dedicated to understanding how these spacecraft would navigate interstellar distances and how we might intercept their potential communications. However, the challenges related to distance, time, and materials engineering pose considerable hurdles that any extraterrestrial civilization would have to overcome. But to prepare for the eventual return of Oumuamua and its possible collision with Earth, we need to understand what this object really is. Why is this object called Oumuamua so peculiar? What have we discovered about it so far? In the fall of 2017, an enigmatically shaped object known as Oumuamua passed through the inner solar system, passing so close to the Sun. Its significance lies in the fact that it was the first known object to originate outside our solar system. Astronomers designated it as Oumuamua, being the first interstellar object discovered in our solar system. However, it is now commonly referred to as Oumuamua. For a long time, astronomers have been anticipating the arrival of an interstellar object similar to Oumuamua. NASA's then Associate Administrator for Science, Thomas Zurbuchen, stated in 2017 that they had strong evidence for the existence of interstellar objects like Oumuamua. Another interstellar object was discovered in August 2019. Unlike Oumuamua, appeared to behave like a typical comet, showing a tail and a coma formed by gas and dust around an icy nucleus. The lack of a tail and a coma in Oumuamua led astronomers to speculate about its composition. Leading theories suggested the sublimation of hydrogen or nitrogen ice from other solar systems as a possible explanation. Interstellar objects are launched into space due to the gravitational influence of gas giants or by massive collisions that tear apart protoplanets. As the first known interstellar visitor, Oumuamua provided valuable information about the nature of other planetary systems. In addition, its shape was unusual. Although initially thought to be 10 times as long as it was wide, later measurements indicated that it was more pancake-like in shape. The minor planet Arrokoth, explored by NASA's New Horizons probe in 2019, is one of several similarly shaped objects observed in the Kuiper Belt. Oumuamua's brightness, observed through changes in its luminosity, was used to determine its dimensions and shape. Although the exact star system from which Oumuamua originated is unknown, in 2018, researchers traced its trajectory back to its original path to the Sun, discovering that it passed close to 4 stars, with HIP 3757, a red dwarf, being its closest encounter. Oumuamua's hyperbolic trajectory indicates that its velocity as it approached the Sun was so high that it was barely affected by solar gravity, allowing it to continue its trajectory away from our solar system. Oumuamua was discovered more than a month later, on October 19, 2017. by University of Hawaii astronomer Robert Warwick through observations made by the Pan-STARRS system. At the time, Oumuamua was 21 million miles from Earth, and its closest point brought it to within about 15 million miles. If you liked the video, don't forget to like and subscribe. I'll see you in the next video, and thank you so much for watching.